I want to make a platformer. I'm actually going to use the ct.js tutorial to help me build one. But I want slopes. I've never really messed with slopes in programming a game before, and so I want to learn how to do that. So first, I'm just going to follow the tutorial here and just get to the point where I can actually attempt to make the slope. So, small issue. The textures here for the different animations for the robot, these are all the same size. They're 96 by 96, but for some reason, the robot walking one in particular is like all trimmed to be right around the player, so I can't get the collision masks exactly how they are with these other ones, and that might cause some problems. Because that means the collision masks will change size depending on what animation I use. It might cause the character to clip into the wall. So I might need to use a different set of sprites for this. I'm gonna think about how to get around this. It wasn't part of the same gallery pack from the platformers, but I did find some slope textures. So I think the idea is I want to just make a custom collision shape using the polygon thing here. So I think that's what I'm going to do. Will this be a triangle? So I'll need 3 of them. Actually, I should make sure the what's it called? What do you call the center? The pivot. The pivot is in the top left here, so I should keep that consistent at least. So all I'm gonna do is, oh yeah, the rotation axis here. So I'm gonna kind of just move these points over here so I can work with them with the triangle. Okay. So that's 0, 0. That can be 0, 128. That could be 128, 128. I want it to be really straight. Because, like, wait, are these different sizes? Okay, I got the appropriate dimensions this time. So, same process. I'm going to change the collision shape to a line strip slash polygon. Remove these points here. So there's only 3 of them to work with. And I'm going to generally get these in the right locations and then just fine tune the positions of them with these fields over here. Okay, so now I have properly enclosed collision for both of these slopes and they're symmetrical. So now I'm going to put them in the game and just kind of see what happens. We're just going to see what happens. So literally all I'm going to do, I'm just going to generate templates for these. And the only thing we did in the tutorial is change the collision group of these to solid so that the collision code recognizes these as actual obstacles. So I'll put a, oh goodness, those are large. Okay. Well, you know what? That'd be fun. That'd be a fun thing to test. So that's fine. They're larger than I expected. They did come from a different asset pack. I shouldn't be so surprised. Okay, so this is what happens normally. The character gets stuck here. It does line up flush with the slope, but yeah, I can't walk up it. So yeah, we'll definitely need some kind of collision resolution that makes it so that the robot can still keep going forward and upward. I've drawn a diagram here to help me understand how exactly this slope should function, because there's actually quite a few things, quite a few different ways you can implement it. I think for me, what I would want is this character walks forward some distance, let's say up to here. And one way to do it is to just let him go this distance, do a collision resolution, and just like push him upward. so that he's like on top of the slope. And there's another problem of, well, do I want the character to have like this part, like find all of the parts that are touching the slope and bring them all up until none of it's touching anymore? Or do I want it so that he's going like halfway into the slope and it's just the center part that needs to be lifted up? So that's one thing. And the other thing is, I don't think I want him to be lifted straight up, because if there's a very steep slope, that means he's going up this slope like very quickly. So it's actually the hypotenuse I want to worry about. So if he goes this distance, you should actually go that same distance but up this slope. Um, which is, it's going to be, you can imagine like some circle or whatever. Okay, I think I figured it out. So imagine you're moving some distance L along this slope. This would be your move speed. But you want to translate it to L units going up the slope, which is a different distance. So first of all, you need to know this angle, which we can figure out as long as we know the difference in height changed between the previous frame and the next frame. So this is y1 to y2. So knowing that, we take the difference of y2 and y1 divided by L and take inverse tangent of it to get our theta. And then once we get our theta, we can put it into these ct.js utility functions called ldx, ldy to get the direction, the x component of the length, assuming it's going at some angle theta. And then we can basically just split to get the x and y components and then move the character that amount of x and y for the next frame. So I'm going to try and implement this and just see what happens. All right, let me show what I have so far. So I had to modify the movement code a bit. It's going to be kind of custom, which is, it's just how it is. So the H speed stuff hasn't changed. If you hold down the move X to go left, you're going to go left. Otherwise, you're going to go right if you press down the right button. Otherwise, your speed will stop. H speed is then just added to your X position. This will be changed. But the gravity stuff is a little more simple to explain, even though it doesn't look simple. So basically, there's this code where if there's ground underneath you, and then if you are holding the jump button, then you will jump. Your V speed will be set to a jump speed. Otherwise, you hit the ground, you don't want to jump. We'll set it to 0 so you don't go through the floor. And then same thing with if there's ground above us and we're moving up, we also want to stop the V speed because you're bumping into the ceiling. So that's the other case for setting V speed to 0. And if neither of those cases are true, then we let gravity take effect. So we add gravity to our V speed. We also clamp the falling speed, so you can't fall an arbitrarily large amount at once. This clamps from negative infinity to max speed, so you can jump up, you can go up as fast as you can. You just can't fall down as fast as you can. And then, kind of jank, but this is how I'm resolving collisions. Basically moving one pixel at a time, taking our V speed. If we're moving down, we'll check under us for every pixel that we need to move with V speed, and then just set our Y that amount. This obviously won't work if you have a fractional speed, but that's not something I'm really concerned about for this scenario, at least not yet. And then for moving up, if you're moving up, then again check above you one pixel at a time for occupied space, and then move one pixel at a time for your negative V speed. And let me show you how that looks. I'm not using CT delta for this scenario either. So you can tell here the movement in the horizontal direction isn't functioning yet as intended, but you can see he jumps fine, and you see he stops when he hits the ceiling, which is what I want. So now I just need to resolve the horizontal where I want to basically climb up a slope, but at the same time stop when I hit like a wall like this. And I need to, that's going to be another challenge is making sure the game understands when I'm hitting a wall and I should stop versus when I'm hitting also a wall here, but it's sloped, so I should actually slide up it a little bit. All right, very cool update. So that code where I just was adding the h speed to this.x has been replaced with this. So now what it's going to do is a bunch of janky math stuff, which I'm sure I can optimize later. But basically, I'm trying to find after the object moves, the robot here, the supposed x position, or the rather the amount of horizontal displacement that needs to go, how far up that robot needs to go before it's not colliding with an object anymore. So that's what delta y is. So from the x and the y change, I can now calculate what the slope of the platform that the robot just went through using this formula. Just making sure this is positive, but taking delta y over the length, and then arctangenting it, and then making sure that's in degrees, and that's my angle. And then I could figure out how much the character truly needs to move to the right or left using LDX and then passing in the speed and the angle. So it's a projection onto the x-axis. So the higher the slope, the steeper the slope, the slower the robot will go left or right. And then now I need to know the true delta y, how far the robot truly needs to move, because now I want to use this speed basically instead of the h speed. So then I basically have to do the calculation again where I'm checking at that position that the robot will go to, and then looking up, up, up until there's no more platform that the robot's colliding with. And then I can change the robot's position to the x and y values. And let me show what that looks like so far. I also created a new slope here because I want to test different slopes. And look at that. Very smooth. And it's very subtle, but the robot does slow down when going up a slope. And I'll show it here. It even works for the steeper slope here. He's going the same speed overall. It's just his direction's changing. The point is that the change in the horizontal speed is decreasing, which is what I wanted. Now, there is one thing I haven't taken into account, and that's walls. So, yeah, right now the game thinks walls are just very, very steep slopes. So it's just gonna try and just jump right up toward it. So obviously I need some kind of like limit to say whether something is basically a wall or not. Because the game doesn't know. It just thinks it's a really steep slope, and that's not its fault. So I'm going to set a limit for that, which shouldn't be too bad, actually. Okay, it was a pretty simple change. So here's the slope calculation part again. I didn't change anything else, I think. I just needed this extra if condition. So we're going to check if we're moving horizontally, but also we're going to check kind of ahead of time if the position we're about to go to is basically too tall to reasonably run this algorithm. So that's what this is. It's going to check the current position plus the speed, so wherever position we're about to go to, and then it's basically going to look a certain distance up dependent on the horizontal speed. So the faster you're going, the more this value goes up. And then I just have this like max slope value that you can configure here. So basically if this slope value is 1, the max the character can go up is a 45-degree angle. So it's like a, rise of 1, run of 1. So if the slope value, I have it set to 3 here, which I think is a decent, I think that's a decent number to go with. Then it's basically, you can go up a slope of 3, like 3 times high, 1 time across. And let me demonstrate that, because it's very Cool, and it just works. Everything just works now. I'm gonna go up these two, and here's I was testing if it can catch these little walls here, and you see it's pretty accurate. It knows it can't really like go up it, but if you get it small enough, that if you make the step small enough, you will go up it because it basically recognize it's basically a slope at this point. So you can configure that uh, again with this slope value. So that's the idea there. So if I set this to like, I don't know, 12, that means you can go up a really steep slope. But notice it's still pretty dang good with walls. Yeah, it does. There's this thing where like you can edge jump basically, which I think is pretty funny. Basically, because you're like clipping all the way up here at some point, and then you can get like an extra jump out of it. Let's see, yeah, now that the slope is higher, it counts that as a slope. I don't think it counts. Oh, it does. This one also counts as a slope. Yeah, I have. It's actually pretty dang good. There is one thing I noticed that's a little problematic. I can't actually jump off of a slope if I'm moving down it for some reason. I can if I'm standing, and I can if I'm moving up it. But moving down, it's not possible. So I'm wondering if it's because of like how the movement logic's working, where I'm moving and then I'm calculating whether if there's a platform under me, and I'm basically like always in the air by the time it checks if I'm able to jump. That's my current theory, but I'm going to figure out what's going on there. Okay, I think I figured it out. So, first of all, I don't want to calculate the horizontal movement before the vertical movement. So, basically, this slope calculation and this h speed update code, it's going to run after calculating the vertical displacement. So now this is at the bottom, and now the gravity stuff is at the top. And secondly, I want to perform the moving update with the gravity involved before I check if the jump key has been pressed. So I think what I want to do here is just copy this and then put this afterward, which it's a little weird, but I'm basically going to be checking this twice, I guess. I don't know if I should remove the first one because this case it's not going to actually update the vertical speed until the next frame. So that's the problem there. But if I do this, and basically just check for this case here, and then basically don't check for it here. Now it's going to do all the vertical displacement, and then it will check if I'm in contact with the ground. So I'm going to check if that works. Oh, that's interesting. See that? My horizontal movement stops when I'm hitting the ceiling. Okay, but that works. Look at that. Now I can jump off of a slope moving down it. This is interesting. Did my changes cause that? Let me reset this. Or was it always like that? Oh, interesting. It was always like that. Okay, so there's also another kind of issue where I'm hitting the ceiling and my character slows down. So I found some of the problem. I'm going like, I think I'm going half as fast as I should be because of these loops. So I'm looping from 0 to the h speed value and then just moving my character one pixel at a time. But I'm also changing this value of h speed on every loop, and it's going to be rerunning this logic and me editing this as it's running through the loop and decreasing at the same time means it's gonna have like half the number of iterations I expected it to have. So I gotta change it so it's not editing its own value that's checking against on every loop. I'll probably make this a while loop or something. Yeah, see, this makes a lot more sense and it looks cleaner. So I'm just checking for moving left. Um, wait, wait, this is moving right. I just realized this is moving right and this is moving left. So if we're moving right, I'm checking to the right of me, and as long as there's not a position of a solid object to 1 pixel to the right, and as long as I have h speed to go through, then I update the position there. And then same thing with moving left. Just check 1 pixel to the left of me every time, and also make sure I still have negative h speed to go through. Am I faster now? I actually can't tell. But yeah, look at that. Now it's fixed. Because I was actually only going like half the speed under some circumstances for some reason. I don't fully understand it, but I knew that was at least an issue, and everything else is working, so that is very cool. Alright, there was one more optimization I wanted to make. This double while loop is kind of stupid, but it also like almost it pretty much just guarantees I won't run into a glitch. I could remove this part where I'm just bumping this the Y value up every time, 1 pixel at a time to try and find the Y position the character should be at. But really I should be able to just make a delta Y by using this formula that I did for delta X. Like it's literally just the same. Like I could just do this. The only problem that I can foresee about this is it's approximate because I'm guessing what the angle is, so I'm worried if it's even slightly off, the character's going to get stuck on the slope and therefore not be able to move around, or like it would just look janky. But I never actually tested that, so this is what I'm going to do, is test it and just see what happens. So now I just got rid of like a whole extra loop of it, like trying to determine what Y position to put itself in while going up or down a slope. Well, really just up a slope. Delta Y has already been declared. All right, it's got to be true delta Y. So let's see what happens. Maybe it'll just work out and everything will be fine. Uh-oh. Oh, oh, what? Oh, no, that is the problem. It's positive going to the right. So it's pushing the character down as I'm trying to go up the slope. Oh, that's actually okay. That's actually kind of funny. Um, yeah, so obviously, even though the HB changes, I don't want it to. We're gonna do an absolute value, just force this value to be positive, and then make it a negative offset. There's gonna be no case where I will want the Y to be positive and push the character down walking on a slope. I cannot envision such a situation. Oh, look at that. That works pretty well. I can still jump off a slope, even going down both directions. No, actually, yeah, that saves quite a bit of computation in theory. No, it looks like it functions the exact same. So my only the only reason I was hesitant to change that is the case where you have a curved slope. Like you can imagine this slope starts off steep and then like tapers out to be flat, and then the character's going up it and it's curved. So calculating the slope then becomes more approximate, like it wouldn't be as accurate. And so I was worried the character would get like stuck in that case. But I honestly, that's probably okay because the character's being translated so it's only a few pixels per frame, So like it's very slow, increments of horizontal translation. So the approximation is still going to be pretty accurate, it looks like. So that's good. So this, I think I will keep this. I just realized the sound for the game being saved is really loud, so I want to disable that for future endeavors with ct.js. But there's one thing I want to try just to be sure. I wasn't sure how I was going to respond to sloped ceilings. Oh, whoa. Oh, that's interesting. It like keeps the gravity of. Oh, what the heck? Hold on. All right, more testing is required here. It doesn't curb the vertical speed if you're like. Okay, it does stop if you're like walking towards it or just jumping up directly. If you're going to the left, I don't think it counts as you hitting the ceiling, so you just kind of like starts. Oh my god, I can't even do it. It just counts as you sliding up. That's kind of funny. There you go. Uh, I mean that's kind of cool. Not not you don't necessarily want it removed. Could be could be a fun little thing that you could do. Again, it's all in context. It totally depends on what kind of platform you want for your game. It could be a good thing or it could be a bad thing. All these different parameters that you could set or different like ways you could implement slopes. Totally depends on your game, but I feel like what I've written is a pretty good baseline. So what I'm going to do is I'll probably package all the assets here and put it on a GitHub project so people can just download this file or the folder with all the contents here for themselves. Just load it up in ct.js, take the movement code that I made for the robot, and harness the power of slopes. Because I think most people wouldn't really get this on their own, so I'd imagine it'd be pretty useful. I guess that's it then.